So let us start with what we know. So what we have here is a circle on the XY coordinate. So you know when you plot points, it could be anything. Like I could be way over here and it's like 5, 5, right? Positive, positive. Over here it would be negative 5, 5. Down here it would be negative negatives. Down here it would be positive negatives, right? Okay, so the circle is like superimposed on that graph. So what's happening is that there are coordinate points, x, y points, all the way around the circle. And that's what this video you're about to watch for me for Tuesday is going to show you. It's going to all of a sudden throw out some points at you. And I want to give you a little background on where they came from. Before we go there, though, let's talk about the angles that we've talked about this week. Let's put those on here. So if we start with our basic angles, we know that 0 degrees is here. 90 degrees, 180, 270, 360. Now, obviously there's a lot of angles in between, right? So there are a few that we focus on. We don't obviously do every angle because that's just too much. But we basically do the 30-degree angle, the 45-degree angle, and then 60-degree angle. And we'll repeat that in each quadrant, and we'll build it. Miss Maxwell said she can see you now if you want to. Do you want to go now? I'm recording this, so if you need it. Yeah. Yeah, just take your stuff with you. All right, so if I keep building across, I'm just going to use those same increments as I keep going. So if I go 90 and add 30, I get 120. If I go 90 and add 45 degrees, I get 135. 90 and add 60 degrees, I get 150. And then it's like same song, third verse. I'm going to add 30 degrees to 180, I get 210. 45 degrees, 225. And then 60 degrees gets me to 240. And then lastly, if I add 30 to 270, I'm at 300. 45, I get 315. And then I get 330 if I add 60. Bye, Brianna. Good weekend. All right. So far, so good. These are the angles we care about, all right? Now, then the next day we talked about radians. Where the heck is a radian? How do we build this? So I'm gonna write on top of these the radian equivalents, okay? This was 0 radians over here. 180 was pi, remember that? So if we break that in half, that means that 90 is pi over 2. And then anybody remember what 270 was?
2 pi.
Almost. 3 pi over 2. Because it has to be more than 1 pi, right?
Yep.
So 3 pi over 2. So 1.5 pi's. And then a full revolution is 2 pi. All right, now, if you recall, we spent that whole day breaking up those pies into fractions, right? And reducing the fractions and all the things. So instead of doing all that again, will you just trust me that I can tell you what those fractions were? We can write them on here. Good, thank you for trusting me. All right, so pi over 2, if that's 90, this one was pi over 3, this one's pi over 4, and this one was pi over 6. All right. Over in quadrant 2, this one was 2 pi over 3, 3 pi over 4, and 5 pi over 6. Quadrant 3, it will go 7 pi over 6, 5 pi over 4, and 4 pi over 3. And lastly, this one will be 5 pi over 3, 7 pi over 4, and 11 pi over 6. Now, before I add any more detail to this hot mess, I want you to look at the degrees. Seem to digest pretty easy for students because we're used to that, right? So how are we going to remember these radian angles? Well, I want you to look at these angles and see if you see a pattern. It's nothing high-level math. It's just looking at the numbers and seeing if you see a pattern going on here. What do you see? 6, 4, 3, 2, 3, 4, 6. See how it makes a pattern? So if you start here, can you remember pi over 2? You start at 2 and then you count down 3, 4, 6, 3, 4, 6. Those denominators match, right? And then look down here. If I start here, it just goes up. 3, 4, 6, 3, 4, 6. Huh, fancy, huh? Do you notice that all the numerators have a pi? So you don't have to remember that. But now we need to figure out how many pi's are in those numerators. So quadrant 1 is easy because it's just 1. What about quadrant 2? Do you see a pattern here? Very nice. The numerator is 1 less than the denominator. See it? So if you can do your 2, 3, 4, 6, then you can figure out the top. What about quadrant 3? So this one's a 1 less. What about down here? It's 1 more, isn't it? What about over here? It's a little extra step here. Well, there is one. Okay, but there is a pattern. They are all odd. Yeah. Double minus 1. There you go. Double minus 1. If you double the denominator and subtract 1, there it is. That's why they're ending up prime. Do you see it? Okay, but there's a lot of odd numbers there. Which odd number would it be? If you know your denominator, double minus 1. All right? So, degrees, radians. Now we need to add xy coordinate pairs to every one of these. But there's a pattern. There's a pattern. Once you learn one quadrant, it just copy, paste, copy, paste, copy, paste. All right, trust me on this? Because we're about to go into geometry world. We okay? Will you trust me? What I'm about to show you, you are not required to recreate. You just need to trust me. This is where these points came from. Okay? I'm just going to walk you through it. I'll be there for you. It's fine. All right, so let's start here. Let's say I draw a triangle right here from the origin to the 30-degree angle and straight down. Can you visualize that little triangle? Okay, so I'm going to put one on a sticky note right here for you. Let's say I have my triangle. Okay, this is 30 degrees. That's 90. So what does the other angle have to be? 60. Remember that? Yeah. Does anybody remember what we said the radius of this circle would be? 1, because it's unit, 1 unit circle, right? So if my radius is my hypotenuse, that length is 1. So I can then find the lengths of the missing sides. All right, now, here we go, diving deep. Back in geometry, you learned about 30, 60, 90 right triangles. There was a pattern to it. Anybody remember it? I'd be real impressed if you do. No? Pattern looks like this, x squared to 3, and then 2x. Now, what the heck is that? How's it going to help me? Well, I kind of work it backwards. So what I know is that the side across from my 90-degree angle is a 1. So it's like I can set up an equation with this guy. So this is like saying 2x equals 1. Then what does x have to be? 1/2. Does that make sense? 2x equals 1, then x must be 1/2. So that means this side right here, the side opposite my 30-degree angle, is 1/2. And then you just plug it in for the next one. So it's basically square root of 3 over 2 for the cross from the 60-degree angle. Does that make sense? Now, why do I care? Well, here's why I care. This distance is the horizontal distance of this point right here, isn't it? The horizontal distance is also known as your x value. So that coordinate is going to be square root of 3 over 2. This distance is the vertical distance of that point, which makes it a 1/2 for the y. So my coordinate pair right here at 30 degrees is going to be square root of 3 over 2, comma, 1/2. There's my x and y.
We can't use this on our assignment, can we? It says not to use it.
It does?
What? Yeah, it says not to use it.
Well, you can recreate it. I don't really care right now if you use it on your assignment because you're just learning it.
Okay.
We're working towards not needing it. Okay. All right. We cool with that? Okay. That being said, that was quick. All right. That being said, that little triangle. Oh, bless it. That didn't come out right. There we go. All right, so we said that this is going to be square root of 3 over 2, comma, 1/2. Now, we're going to use that same coordinate pair at every 30-degree angle from the origin. So if I fold this over, just visually take this point, fold it over here, doesn't that land us right here? How do my coordinates change sign-wise over here in quadrant 2? X and Y, are they positive or negative?
X is negative, Y is positive.
Right? X negative, Y positive. So the same coordinate's going to match over here. It's just my X became negative. And then 30 degrees from the x-axis going down puts me at 210. So now in quadrant 3, they're both negative. And then quadrant 4, it's that 330-degree angle. So here, they're going to be, your x is positive, but your y's are negative. So far, so good? All right, now the next angle or triangle we would create is a 45, 45, 90, because this angle from the origin is 45. Do y'all remember that these are isosceles triangles? And the radius is still a 1, right? And the old pattern for the special right triangle said this, 45, 45, 90. These sides are equivalent, and the hypotenuse is x squared root of 2. So if I know that this is x squared root of 2 equals 1, so if I do the algebra, so x has to be 1 over the square root of 2, but I can't leave it like that. Right? I have to rationalize it. So when I rationalize it, I end up with the square root of 2 over 2. Does that ring a bell? So what does that tell me? That tells me my two side lengths are equivalent, square root of 2 over 2. And that my y is the same as my x. So, coming back over here, that means at 45 degrees, it's square root of 2 over 2. Positive, positive, right there in quadrant 1. So my 45-degree angle in quadrant 2 is at 3 pi over 4. So all that's changing is my x coordinate is negative. In quadrant 3, they're both negative. And in quadrant 4, just the y is negative. Oopsies. Okay? Now, last but not least, let's do the 60-degree angle. Oh, that's terrible. So if this is 60, this is 30. Uh-oh, this was that pattern we just did, isn't it? We know the hypotenuse is 1. This was 1/2, and this one was square root of 3 over 2. Remember? Yeah. So that means my x-coordinate now is 1/2 because the short end is across from the 30. And the y-coordinate is the square root of 3 over 2. Just flipped, isn't it? It's just the flip of this angle, this coordinate. Exactly. And again, we just watch our signs. Alrighty. Then, very last but not least, probably the easiest points to figure out are the ones that land right on the axis. Okay? So like right over here at 0 degrees. Look, the horizontal distance is a 1. What's the vertical distance? 0. So this coordinate over here is 1, 0. Oh, dang it. If you're still with me, it's 0, 1. If not, we'll finish it Monday. -1, 0, and then this one's 0, -1. We'll revisit it Monday or Tuesday because it's something we need to know and memorize, okay? It's your first pass at it.